All right, happy Tuesday to you all. Um, Couple things we got to talk about. First of all, those of you who voted for the pink ceiling, I don't know what to say. Well, I'm kind of happy I don't have to paint, but that's ridiculous. Uh, there had to have been some tampering in the votes. I'm sure the Russians had something to do with it. Um, yeah, but I guess the ceiling stays pink. Let's see. There's a couple things I'm going to go through in your notes. If you don't have them, print them off quick. Print them off. I'm going to bounce around a little bit, so if it feels like I'm bouncing from one topic to the next, I'm just going to hit the key things. I'm not going to go over every example. We'd be here all day. So if I go too fast, pause, rewind, and you can get it to slow down. So the first thing we got to talk about is the counting principle. Many of you, we talked about it in class, some of you not. The counting principle is basically when you just write out the number of ways there is to do each thing. So the example we talked about is the number of ways to have an appetizer. The soup or the salad, there's 2. Now the number of ways to have a dinner. You have beef, chicken, vegetarian, that's 3. And then the number of ways to have a dessert. So you just write out the number of individual ways for each one, then you multiply. So 2 times 3 is 6, times 2 is 12, so there's 12 different dinners that we can have. From there, we move into factorial. And factorial is actually not different. When you have 4 factorial, that's 4 times 3 times 2 times 1. What factorial is if we go down here, factorial is the number of ways you can order. And when I say order, I mean put in order. You can order n things. So if I wanted to put it in the exact same light as what we had up here, we had the number right here. If I want to find the number of ways, I can take J, R, and O, and how many ways can I put them in order? Well, we said we're going to do this without replacement. We said the first letter, there's 3 ways. You could have a J, an R, or an O, but once you use it up, it's used up. The second letter, there's 2 ways that you can fill it out. And then the last, there's just 1, which is 6, which is 3 factorial. So if you want to think of permutation or factorial as the counting principle with no replacement, that's exactly right. It's exactly the same idea. We're going to skip some of this now, and it jumps into permutations. So right here in your notes, we're not going to fill all this out, but if we want to think about what a permutation is, a permutation, I'm just asking, what's a permutation if you have to use all 4 letters? A permutation is, all it is an ordering. Putting things in order. And it says that you have to use all 4 letters. So one example of that would be A, B, C, and D. Or if you just switch the order between the 2, you have B, A, C, and D. And obviously, if you list them all, it's going to be a ton. Okay? So the better way to do it is using what we call the counting principle. How many ways are there to fill in the first blank? Well, you could pick 4 different letters. How many ways are there to fill in the second? There's 3. How many ways to fill in the third? There's 2. And the last one is 1. So you'd have, the counting principle says there's 4 ways, 3 ways, 2 ways, 1 way to fill each blank, and then you multiply. 4 times 3 is 12 to 24. So the answer is going to be 24. Now notice, that's also n or 4 factorial, and that's correct. That's the exact same thing. If you had to use permutations and you're going to use all 4 numbers, n factorial is exactly the same as npn. Meaning, if you have to use all 4 letters in order to order them up, then n factorial and the permutations are exactly the same. I'll remind you how to hit buttons on your calculator and find that in just a second. All right, now let's say where it becomes different. Notice that factorial has to use all the letters. You have 4 letters, then 3 letters, then 2, then 1. Permutations can only use 2. So a permutation, we're going to have the letter A and then B. We're not going to use all 4 letters, just 2. And then B followed by A. And then B and C and B. Notice if I switch the order, it counts as something new. That's unique to permutations. If we want to use the counting principle, we would say this. We would say, how many ways are there to fill the first letter? There's 4. How many ways are there to fill the second letter? There's 3. So there's going to be a total of 12 different ways that we could pick 2 letters, and that's right. If we wanted to use permutations, we would say that there's 4 letters to choose from, but we're only going to choose 2 of them. And the fact that I put a P here means that order matters, meaning A, B is a different option from B, A, and B, C is different from C, B. On your calculator, if you want to check that out, here's what you have. You're going to hit math and then go over to probability right here. And if you notice, you have your NPR and your NCR. So I'm going to pick NPR, pick a 4 to choose from. I'm going to choose 2 of them, and you get 12. So that's what your calculator's doing. If you notice what it is, guys, it's a factorial that's been cut short. Factorial is going to go 4 times 3 times 2 times 1 all the way down to 1. Permutations, it is factorial, but it's been cut short. 4 times 3, stop, and not have the 2 and the 1. For the next one, how many permutations are there if you use all 4 letters, but you eliminate any option that contains the same letters? Meaning, if these 2 are not counted as 2 separate things. If these 2 are counted, but we're just going to count them as the same. That's just one option. Same thing here. This would be one option. So it says we're going to use all 4 letters, and if you notice up here, there was 24 different ways to use all 4 letters. Let's think for a second. So here I wrote out 2 of them. Here would be another one. A, B, D, C. A, B, C, D. Oh, no, I already had that one. A, B, how about B, A, C, D. There we go. And there's 24 of them if I wrote them all out. But notice what it says here. Eliminate any option that contains the exact same letters. Well, under a permutation, these are all different because the order is different. Under a combination, all of these are going to be just counted as 1. Anything that contains an A, a B, a C, and a D, we're going to count it as one thing. These are called combinations. So for here, how many are there? There's only going to be 1. All of them will contain a B, a C, and a D. All right, for the next one, how many combinations? Now notice I switched over to the word combination. Combination means we're going to do the permutation, but then get rid of any option that's the same. I'm going to skip the formula for now. What we would do is we would call that 4C2. 4C2 finds your permutations, but then gets rid of the ones that use the exact same letters. On your calculator, 4C2 looks like this. 4, I'm going to hit math. I'm going to go over to probability down here to 2, 4C2, and there's only going to be 6 ways. So of this one, there's 12 ways if order matters. There's only going to be 6 ways if we don't consider order. I'm going to skip the formula here. Just so you know, there's another notation that comes up in pre-calculus. 4C2 can also be written as 4 over 2 in parentheses. You're going to see this. The parentheses does not mean permutations. It only means combinations. All right, so I'm just going to give you a bunch of examples. I want you to pause it and try as many as you can. I want you to figure out, is it a combination or a permutation? Like I said, pause it, try a bunch, try some on the next page, and then we'll discuss. So for each one, there's 10 students here, and from them we're going to pick a president, a vice president, and a secretary. Notice they have very specific roles. So I say, hey, there's a president. Now, how many people could possibly be the president? 10 different people. Well, once you pick a president, he can't be vice president, so that means that 10 is used up. So 9 people can be vice president, and only 8 people can be secretary. Okay, notice this is the beginning of factorial, 10 times 9 times 8. This is the counting principle, where you just take the numbers and multiply them. But these are permutations. Permutations means order matters. Like, people have specific roles. Once you have a president, if you pick someone to be president, vice president, and secretary, and you pick those exact same 3 people, but just give them a different role, then that's going to be a permutation. I'm going to go on my calculator. You can either just multiply. I can see that it's 720, or we can go here and go math over to probability, pick 2 for NPR and go 10, 3, and get 720 different ways. For the next one, notice they do not have specific rules. There's 10 students. We're going to form a 3-person committee. Okay, 3-person committee. So when we do that, we're going to do this 10, 9, 8, and get 720. But within that, we're going to get rid of anything, any combination that is the same group of 3 people. So if I have 3 people that I choose, one of them's president, one's vice president, and one's secretary, and I just take the president and the vice president, and if I switched them, well, under this, the first one, that's a new option. Under this one, that's not new. If we just have a committee, they don't have roles. There's just 3 people. So if we switch them up or mix them up, that's not a new group. We're going to call that a combination, and I'm going to call it 10, choose 3 using a combination. Notice there's going to be far fewer because we're getting rid of the ones that are the same group of people. We're going to go over to probability, boom, choose 3, and there's only going to be 120, so notice we got rid of a bunch of them. All right, try these. I'll keep going. A cook chooses 5 potatoes from a bag of 10. Does it matter what order you pick the potatoes? If we're making mashed potatoes, they're all going to get thrown together anyways. So those are combinations. We're going to go 10, choose 5, and I'll let you punch the buttons. A teacher has 15 desks and 13 students. How many seating charts can they make? Well, notice that if I take 2 people and switch them up, that's a completely different seating chart. We have permutations. So we're going to go 15, permutation, 13. Different ways that I can choose the people. A pizza company has 5 toppings. Hey, my kids just walked in the room. They want to say hi. Don't sit there, please. Okay. A pizza company has 5 toppings, and a customer may choose 3. How many pizzas can be made? Well, think about order doesn't matter. If you put pepperoni and then sausage and then sauce or whatever, the order doesn't matter on that. So we're going to go 5, choose 3, and like I said, that's a combination. And you can punch the buttons for yourself. Last one's tough. Pizza company has 5 toppings, and the customer can choose as many as they like. You can have 0 toppings. You can have 1 topping. You can have 5. That's a little bit different. Well, here's actually the counting principle. This is not a permutation nor a combination. This is the counting principle. Okay, so let's get to topping number 1. We'll just call it sauce. Well, how many options can you choose for topping number 1? Well, there's 2. You can have it or not have it. Get to the second one. We'll call it pepperoni. How many options are there? You can have pepperoni or no pepperoni. Get to the third one, sausage. You get the idea. For each topping you pick, there's the decision of having it or not. So this is actually 2 to the 5th power, or 32 different pizzas that can be made. Tricky stuff. If you wanted to think of it in combinations, order does not matter. So we would think of it as this. 1 pizza you could pick is 5, choose 0. Well, another pizza that you could pick is, you could do 5, choose 1. You could choose out of the 5 just to choose to have 1 topping, and obviously order does not matter on a pizza. And then, or 5, choose 2, 5, choose 3. You get the idea, and you would take all of these options and you'd add them all up, and that would give you the same result. Personally, I like the counting principle.